Good afternoon, students. We're going to talk about graphing rational functions, looking at discontinuity and vertical asymptotes and holes. We just finished the unit on just simplifying rational functions, and that's using all the math that's needed to simplify rationals. And now we're going to look at the graphs, so we're going to look at the rational equations and see what it tells us about what the graph is going to look like. So first you need to understand what discontinuous means. Here's a brief definition. Discontinuous means that the graph is broken or split, and that means that you have to pick up your pencil and start again to finish the graph. This comes from the graph having asymptotes or holes. So we're going to be finding the asymptotes and the holes in this lesson. Alright, the math that is involved in finding out what the asymptotes and the holes are is the very first thing you're going to do is you're going to factor it, and then you're going to cancel off any common factors, and then we're just going to clean it up. Then to find the vertical asymptote is going to be at all of the zeros of the denominator. And if you've forgotten how to find the zeros, that's okay. I'll do a brief review over that. The holes are going to be found at anywhere that the zeros canceled. So let's look at a couple of examples. Alright, so in our first example we have y equals 2x squared minus 4x divided by x squared minus 4. Okay, well the first thing that you're going to do is you're going to factor it. Now in the numerator, what I notice is that it has a common factor. It has a common factor of 2x. I can divide everything by 2x. So if I divide 2x squared by 2x, I'm going to be left with x. And then divide minus 4x divided by 2x would give you minus 2. So let's mark that out. Okay? And then on the denominator, it's x squared minus 4. Well, that's a difference of squares. So you're going to have x plus 2 times x minus 2. Okay, let's cross that out. Okay, then you want to cancel off any common factors. Well, I have an x minus 2 on the top and the bottom, so I'm going to cancel that off. And so what my new equation is y equals, on top I just have a 2x, and on the bottom I have x plus 2. Now remember, you can't cancel off those x's because this x plus 2 is a group. You can't cancel off the x's unless it's separate. Okay, so here's what I have. Now what this does is in order to find, well now I've got to find the vertical asymptote and I've got to find the holes. Okay, and that's going to tell me where the graph is discontinuous. Well, the vertical asymptote is found by looking at the zeros of the denominator. Well, remember, to find the zeros, you just set it equal to 0, and then you solve. So x plus 2 equals 0, that means that I have a 0 at x equals negative 2. So that's where my vertical asymptote is. And then remember, the holes are where they come from the factors that canceled in the denominator. So this is what canceled right here. And so if I find the 0 of that, x minus 2 equals 0, it would be x equals positive 2. So I'm going to have a hole at x equals positive 2. Okay, so here are the places that my graph is discontinuous. Remember that the vertical asymptote comes from the answer denominator. I'm just going to put denom to save space. And then just remember that the holes come from anything that's canceled. And in this case, the x minus 2 was the one that was canceled. And so that's where I'm going to have a hole. Okay, looking at example 2, I have y equals 3x divided by x squared minus 9. So my numerator is already factored, but my denominator is a difference of squares, so I'm going to have x plus 3 times x minus 3, and I'm going to mark that off. Now, as of right now, nothing cancels, because again, remember, this is 3 times x. That's different than x plus 3, so don't try and cancel that. There's nothing that cancels. So, my vertical asymptotes are going to come from the zeros in the denominator. Well, this one is going to give me x equals negative 3. And this one is going to give me x equals 3 when I set them both equal to 0. Okay? The wholes come from anything that cancels. So there was nothing that cancels, so there are no wholes. Alright, in this third example, I have 4 minus 4x divided by 2x squared plus 5x minus 7. So one thing that I've noticed is in the numerator, let's rewrite this to be in descending order. So it's going to be y equals negative 4x plus 4. I'm just rearranging it to put it in descending order. And then this can factor. I can divide out a negative 4. You always want to divide out that negative because we don't really like our leading coefficient to be negative. So if I divide by negative 4, I'll be left with x and then minus 1. Okay, I'm going to cross that out. Okay, and then in the denominator, I have 2x squared plus 5x minus 7. Well, there's 3 terms there. It is a quadratic, so you're going to do the box method to factor it. Remember, for the box method, you put the first term in the first box, last term in the last box. You multiply those together, so we have to make our little chart over here to fill in the rest of our box. It has to multiply to give you 14x squared. That's what you get from multiplying this times this. Okay, but it has to add to give you that middle term, which is 5x. Well, the only way that happens is if you have a positive 7x times a negative 2x. That does in fact give you a positive 5x. So remember, that's to fill in the rest of your box. So I'm going to put a 7x there, I'm going to put a minus 2x here, and then to get my factors you have to factor out the GCF. So the GCF in this first column is a 2x, in the second column plus 7, in the first row x, in the second row just minus 1. Okay, well those are my factors. So I'm going to put those here. So I have 2x plus 7 times x minus 1. So that's how my denominator factors. Okay, then I can cancel off my common factors. So the x minus 1's cancel. So my new rational equation is y equals negative 4 over 2x plus 7. Again, remember that the 2x plus 7 is a group, so you don't try and cancel off the 2 with the 4. Okay? And now let's write down what our vertical asymptote is. The vertical asymptote comes from setting the denominator equal to 0. So if I set this equal to 0, I'm going to have 2x plus 7 equals 0. I'm going to subtract 7. And then I'm going to divide by 2. So my vertical asymptote is x equals a negative 7/2. If you want to write that as negative 3.5, that's fine. My wholes, remember your wholes come from what was canceled. Well, this is what was canceled right here, so I have a whole at x equals 1. Okay, and so here is your equation, and here are your vertical asymptotes and wholes. Okay, example 4, y equals 7x over x squared plus 5. if you look at trying to factor it, the 7x is already factored. The x squared plus 5, even though it has an x squared, if it has two terms, then really the only way you could do it is do a difference of squares, but that's not a difference of squares, so this is factored. Okay, it can't be factored, so I'm going to write that down here. So now we just need to list our vertical asymptote and the holes. Okay, well, the vertical asymptote is going to come from setting the denominator equal to 0. So if I do x squared plus 5 equal to 0, to solve for x I would have to subtract 5, and then I would have to take the square root of it. Well, when you take the square root of a negative, you're going to get an imaginary solution. Therefore, we have no holes. So, I'm sorry, no vertical asymptote. Okay? And then the holes, well, the holes are found by anything that canceled, and there was nothing that canceled, so again, we have no holes either. Okay, this is going to be the last example that I do, and then I've got 2 examples for you to do to try on your own. In example 5, we have y equals x cubed minus 7 divided by x squared plus 5x. Well, in the top, when we had a cubed, remember we had a difference of cubes or we had a sum of cubes. Well, this might be a difference of cubes, but the 7 right here is not a perfect cube, or we can't, it's not a cube, so that's not going to factor. But on the bottom, we can factor that. We can factor out an x, and we'll have x plus 5 left over. Okay? So what ends up happening is, for my vertical asymptotes, comes from my factors, and I would set both of them equal to 0. Well, x would be equal to 0, and then when I set this one equal to 0, I'm going to get x equals negative 5. And then the holes comes from anything that canceled. Okay, but nothing canceled, so I have no holes. So this is your final answer. Okay, on this example, I want you to try it yourself. Pause the video and then press play when you're ready to check your answer. Alright, so this is what happens on example 6. You have a vertical asymptote at x equals negative 5. You also have a hole at x equals negative 5. And so when you have an asymptote, remember that's like where the graph breaks anyway. So you can't have a hole where there's always already an asymptote. So you can't have a hole where there's already an asymptote. So you're going to still have an asymptote, but the hole you just won't have. Okay? So there's your answer. Okay, example 7, I want you to try it yourself. Remember to factor and then cancel and then clean it up, and state what your vertical asymptotes and your holes are, and it's going to be part of your whisk that you're going to submit to me. Okay, we'll see you in class.